Otherwise, it doesn't get recorded. Now we're recording. So welcome, Claudia and Stephanie and Linda and Vida and Morgan. I think that's the group. This is week 4. And this is, I would say, probably the easiest week of the quarter in terms of new material. So that's good, but why is it not the easiest week?
Project.
The project, yeah. So what I do is I lighten it up. I really lighten up this week because the project is due. We're going to have another project, but at that point, you've already done a project, so you're a little more familiar with it. So this is the easiest one. We may not even take the full hour. There's a good chance we won't, but that's okay. No one complains about that. And what we're going to talk about is the normal distribution. It's also maybe the only week where I'm not going to have very specific like current event applications that I can tell you, because the normal distribution turns out to be used. It is important, really important, but you have to understand the next chapter to understand why it's important, and that's the central limit theorem. And that's a much harder chapter, but much more relevant today. This chapter, I think most people find it pretty easy, and those of you who already posted in the week's assignment for the discussion post, it was one of the easier posts. Hopefully you found that too. It wasn't too much. I haven't, unlike last week where I had to tell everybody, no, that's not right, fix it. I don't think I've had to tell anyone to fix what they posted. So it's, again, it's a lighter chapter. But it's very important because pretty much everything we're gonna do for the rest of the quarter is gonna be based on the normal distribution. Okay, sometimes you're gonna forget that because it's all like in your calculator magic, but it is really important. And I'm gonna show you on the calculator how to do it also, and to look at problems about the normal distribution. So one big reminder, let me grab this, I need water. One big reminder is that the project is due when? Sunday. Don't wait till Sunday to start writing, okay? Because what should you do by Thursday morning?
Turn it into you.
Yeah, get me your draft. I already received one draft, actually, and there was a big issue in it, and I figured I should let you know. I'm not going to name who it was, and I'm also not going to get too specific, but I'll tell you the issue. If you're doing a stratified sample, that does not mean that you have multiple columns of data and multiple means and multiple histograms and multiple stem and leaf plots. Okay, the stratified sample is just so that you can make sure that your data has at least some scientific piece of unbiasedness. Okay, your project is one set of data. So don't give me more than one set of data. If you're doing stratified by gender, don't give me the women's mean and the men's mean. That's not part of the project. It's just what is the mean. So everything should be in one column of data. Does that make sense?
So if we're doing college students, but we wanted to find out how many men and how many, we separated the men and women because
yeah, you made a mistake. So don't separate the men and women. You're just looking at people.
A group.
College students.
Okay, that's our
strategy. Look at what is the average of your college students? What is the average of, what is the standard deviation for the college students? The point of the men and women, if you're doing men and women, is so you don't have bias by gender. Do you see that?
Yeah.
So there's a difference between a comparison study and a study that uses stratified sampling. So stratified sampling is to make sure that you can eliminate the bias in that identified strata. Does that make sense? But you're not comparing one strata to another. You just have your population.
Okay.
So we are asking age group in our on our surveys. Is that going to be an issue because we asked for the amount of pets they own?
Okay, you're asking for the amount of pets. So you're going to have one column of data with a bunch of pet numbers. Right. Once you have asked the survey question, the word age group doesn't happen again. It's not on your spreadsheet. It's not in any charts. Does that make sense?
Okay.
It's not part of your data. Your data is the number of pets people have. And it's people, not this group of people versus this group of people. It's people. Does that make sense? That makes it easier It's much harder to do a comparison study. You will be doing a comparison study for project 2. And then you'll understand why I didn't do it for project 1, because you need a whole lot more math for it. So that's the mistake that I've seen, and hopefully we can eliminate that mistake. Okay, so it's kind of a disastrous mistake.
When is the last day we can submit our project to you to review it?
Okay, so the last guaranteed time at which you can submit it for me to, so you know for sure you're going to get a review by me, is Thursday a.m. Okay? After that, maybe I'll have time, maybe I won't. That's the thing. Because I'll be reading everyone else's projects. And you'll be last in line, and I may not get to it before Sunday. Does that make sense?
Yeah.
It takes me a while to read these. You know, these are like 10 or 15 pages sometimes. So it's not something I can do in 20 minutes. Does that make sense? So if everyone submitted it Saturday, guess what? I'm only going to get to a couple of them, and that's the end of it. Okay? Sunday, I won't read it, period. And Saturday, there's pretty much small chance. Okay, Friday, I teach most of the day. So do you see the issue?
Yeah.
Okay. But if you get to me Thursday, I will guarantee that I'll read it by Friday night. That's my guarantee. If you get it after that, there's no guarantee it may not happen. And then you only get to submit once your draft. After that, you have to post on the discussion forum, and then I'll answer questions. But don't post your entire project. Just post your question and maybe a sentence or two. Does that make sense? Okay. Other questions before we get started? Okay, and they're good questions. I'll tell you, it's something that you may not know, but this is the best class I've ever had teaching online statistics.
Get out of here.
And not because you're beautiful people, which you are. Everybody's doing their work. And for you that do work, you don't understand that usually a lot of people don't do their work. Do you know what happens when people don't do their work?
They fail.
They fail. Yeah. So I have high hopes that maybe nobody will fail this class. It'd be wonderful.
Maybe.
Maybe. I have hopes. I have hope.
Maybe.
Hopefully no one will. Again, usually I have a big group of people.
Linda, I'll call you.
What?
Linda,
Yeah.
I'll call you later.
Okay.
Yeah. Usually I have a big group that do nothing. So hopefully you don't give up. That's the thing. So I have hopes that that everyone could pass, which would be wonderful. Again, with online classes, it's usually about 50%. But this group is not normal. You are wonderful. So that's a good thing.
Well, it reflects the teacher.
Okay. So let me talk about the normal distribution. It's a big deal. And I think I'm going to do it with online stuff first. Let me type that in. Just a minute. Plotter. I had a really good one a little while ago. Let's see if I can get it again. But just a minute. Yeah, this will work. It's not the best one, but it works. Okay, so let me pop this guy in just a second. It takes a moment to get everything set up. And let's go to share desktop. Just a minute. There it is. And let me open the chat so I can read what you have to say. Okay. So what we have here first is what's called the standard normal distribution curve. Okay? It looks like, in a word, what's a one-word way of describing this shape other than normal? Bell. Okay, a lot of people call it the bell curve. In our class, you need to call it the normal curve.
So what?
The normal curve. Okay, see the word normal at the top here? Normal distribution. So we call it the normal curve. In more advanced class, you call it the Gaussian curve, actually, after the guy who came up with it, Gauss. But normal curve for this class is what we'll be using. So this is a normal distribution curve. So I want to show you some notation first. Okay, first is whenever you have a distribution, you have an axis, an x-axis, okay, or an axis. And when you have a normal curve, you write x, and then what I found is most people don't know how to read the symbol. Who knows what this symbol's called? I'm getting a lot of silence. It's not a math word, by the way. Tilde.
What?
Tilde. Have you heard that before? Tilde.
Yeah, you mentioned it before.
Yeah. For those who speak Spanish, it's what's over the N in enye, right? Do we have any Spanish speakers here?
Really? Oh, okay, I got it now.
Okay, so Claudia, you're one of the Spanish speakers? Okay, so it's over the N in enye, right? And in English, you call it tilde. I've asked the Spanish speakers, I've never heard anyone that knows how to say the little symbol over the N in enye in Spanish. Any of you guys know?
Enye.
The enye is the whole thing, though, with the N and the tilde, right?
It's the symbol of enye.
The symbol of enye. But the thing on top is called, and there must be a Spanish word for it, but no one seems to know it, even the Spanish speakers. But hopefully you all know the symbol. And we're going to be using this. So we've used it for uniform distribution also, by the way. So sometimes you'll have x tilde n, sometimes you'll have x tilde u. And we're going to have other distributions also besides normal later in this course. Then comes an n, and I hope you can all figure out, it's not a trick question, what the n might stand for.
Normal?
Normal. Okay, again, not a trick question. So use n to show, yes, we have a normal distribution. Then you have a parenthesis. Do you remember how to read this Greek letter?
Mean?
Mean is what it means. And how do we read it?
Mu.
Mu, good. Kind of like, as the chat box says, like Lynn likes, and what my smartphone says, what my cat says, mu. Okay, so it's a mu. And how do you read the next symbol there after the comma? Sigma. Sigma, and that's the standard deviation. So what we say is that the normal distribution is determined by the mean and the standard deviation. If you have a different mean, you're going to have a different normal distribution. If you have a different standard deviation, you're going to have a different normal distribution. But the shape will always be in the shape of a bell, okay, of a normal, what's called a normal curve. Today is not the day I'm going to be able to explain why this is important. In fact, it is the most important curve in the universe, okay? And that, you have to trust me, I was an astrophysicist, and I understand the universe really well, okay, in weird astrophysics way. So this curve happens a lot, but for statistics, it's also going to happen in just about everything we do. Okay, just a note for your projects, one of the things you're going to do is you're going to look at your histogram, and you're going to see what is the shape of your histogram. Now, it's not going to be ever perfect anything, because in the real world, when you take a sample, you never get a perfect shape of anything. But if it kind of looks somewhat like a bell curve, in other words, if the highest bar of the histogram is in the middle, and then if you look left and right, it tends to go down, then we say it's approximately normal. Any questions on that? So there's a couple words we use for the shape of this, which we've had before. One is unimodal. So unimodal, remember, it has one mode, one hump in the middle, right? Another word we use for the shape of this is symmetric. Symmetric means that if you have a mirror in the middle, left and right are exactly the same. Okay, if you have a normal distribution for your data in your project, do you remember what rule you're allowed to use if you have a normal distribution? Starts with an E. It's important because you're supposed to know this for your project. Yeah, the empirical rule. Okay, everything's good, but you spell it with an I-R-I-C-A-L, but otherwise that was great. So you can use the empirical rule, which, if you remember, says that if you go one standard deviation away, that means that you have 68% of the data. Now, what that tells you is that if we look in between, let's see if I can do this, -1. So there's -1. Unfortunately, with this one, I can only do one at a time. And there's 1. So if you look in between 1 and -1, and you look at the area, it'll be 0.68. 2 standard deviations away. So I'll put a 2 here, but we only get one side with this particular app. So on this, if you look at them in between -2 and 2, so from where my mouse is to 2, you get 95%, or 0.95. If you have 3 standard deviations, you can hardly even see it. It's just about everything. 99.7% of the data, or the area, is in between -3 and 3. Okay, any questions on that? Okay. If you change the mean and standard deviation, you'll get a different curve, but it'll still look bell-shaped. So I'm going to let you choose. Give me a mean. Give me a good number. What's that?
4.
4. And give me a good standard deviation.
1.2.
1.2. And there we go. If you notice, the shape didn't change at all. But if you look, the center of our distribution is now at 4. You see? So the center, or the mode, is at 4. And you'll also know it's a little more spread out than before because sigma is now 1.2 instead of 1. If I make it instead of 1.2, if I make it 12, notice now this curve goes all the way from like -28 to 28. You see that? So it's much more spread out with a higher standard deviation, because that's what standard deviation tells us. Any questions on this? Any questions? Okay. So that's the normal curve, and we can do a lot with it. So I think I'm going to share, we're going to do some problems on this. Okay, and again, as always, if you have any questions, please stop and ask. That's the whole point of the webinars. So let me unshare and then reshare. This. And now let me copy and paste something in. And let's do an example. All right. So here's the question. What it says is, do not use a calculator for this problem. Okay, it's rare that I tell you not to use a calculator, but the point is I want you to understand what's going on with the normal curve. Suppose Z follows a standard normal distribution. Just a note, standard normal means the mean is 0, standard deviation is 1. Okay? So first, find the probability that Z is between -1 and 1. So let me show you what to do. And this is something you want to practice, because on your regular exam, on your written exam, I'm going to make you draw pictures. So it's important that you practice the drawing. So I recommend taking notes and you draw along with me. So the first thing we do is we draw a normal curve. I'm not the best artist, but hopefully you can handle that. So it should look like a bell. Normal-ish, right? And then right in the center, that is at 0 because we have a standard normal distribution. Any questions on that? We want to find out we're between -1 and 1. So let me draw over here and over here. And then we're going to have -1 and 1. Any questions so far? Then what I'm going to do is I'm going to shade in. So I wonder if this will let me do it. Let's see. There we go. Beautiful. I can even make it red. There. So if you look at that, that's part of the answer to the question, is we want to be able to shade in. The other thing I want to do is write the following. I'm going to say z tilde n 0, 1. So when I ask you to write down the distribution, that's what I mean. Z tilde n 0, 1 in this case because it's standard normal. So now, what is the area between -1 and 1? And this is something that hopefully you all should know because I told you already today. Anyone know?
Oh, I'm sorry. What?
What is the area that I've just shaded in?
50%.
What is it?
50.
Not 50. Good try, though.
68.
68. Because the empirical rule says the area between -1 and 1 is 68%, or 0.68. Any questions on that? Okay, for part B, find the probability Z is less than 3. So I'm going to start over. And I'm going to draw my picture again. And now we're less than 3. 3 is way over here. I'm also going to put in the center. It's always good to put the center. And there's 0. Here's 3. And the key on this one, we want the probability that Z is less than 3. Okay? And the key on this one is I'm going to draw the symmetric part of this. If you don't do that, this is going to be really hard. So on the other side, I'm just going to write down -3. I'm just going to put that in my picture. Any questions on that? Then I am going to shade. Whoa. Okay, not that way. Too bad. Let me do it last time. So I'm going to have to shade with my pencil. That's okay. And I'm going to shade best I can. What is that area there? Again, between -1 and 1 was 0.68. So between -3 and 3, if you remember, was 0.997, 99.7%. That's part of the empirical rule. Do you remember that? All right, how much total? If the inside is 0.997, how much is outside of that? And this is supposed to be easy. That's a hint, or pretty easy.
.003.
Yeah, 0.003 because you got to add up to 1. Is that clear? Any questions on that? All right, well, if that is if the combination of this left and right is 0.003, how do we find just the left?
Don't we have to do something with given?
No, it's much easier than that. The key is this is symmetric. So if the total left and right is 0.003, how do you find just this side?
Divided by 2?
Divide by 2, which is 0.0015. Have I lost anyone there? So I want to find out the probability that Z is less than 3. So I can take that far left part and I can add it to that middle part, and that'll give you everything to the left of 3. So that is going to be equal to 0.0015 plus 0.997. And I'll let you do the arithmetic. You know, if you want, it's it's 0.9985. Maybe I'll do it for you. If you add those two numbers together. Any questions on piecing together these areas? Starting to look a little more like math, isn't it? Just to note, I don't know if any of you are advanced in math. Anyone? I think Sean, you've had math, right? Few of you have had math.
Yeah, I've had math.
Yeah. Sean and Morgan have had math. I'm not sure about the rest of y'all, but I mean a lot of math. But this curve is 1 over the square root. You don't have to know this, but 1 over the square root of 2 pi e to the negative x minus mu quantity squared over sigma squared. So there's a reason why we don't have to do all that, because you would probably all run away or most of you would run away if I did all of that. And then finding the area using calculus is really hard, just trust me. So we're not doing it. But what we do need to do is understand the empirical rule. Any questions on that? Okay, so I want to do D. I think I'll skip C and just do D. I don't need to do E also. Okay. So let's look at D, which is find the value of Z such that there's there's a 2.5% probability of being greater than this value of Z. So let me erase all this other stuff. And let's start anew. You'll notice we're always going to draw this normal curve. And then what we're going to do is put a 0 in there. Any questions so far? Okay, we want to find the value of Z such as a 2.5% probability of being greater than the value. So is the value going to be far left, far right, or close to the middle? Without doing any big work. Far left, far right, or close to the middle? If there's 2.5% probability of being greater than that value. What do y'all think? Yeah, it's going to be far right, because if there's only 2.5% bigger than you, you're pretty big. Is that clear? So let's go to big. So that means I'm going to go like this, like so. I'm going to just call that X. I don't know what it is, but I do know this area. This area is 0.025. Any questions so far? Let's shade that in a bit.
So 0.025 is because of the imperial rule?
No, 0.025 because that's what 2.5% is.
Oh.
I moved the decimal over twice to make it a percent, to make it a decimal. So that's just given. Do you see that?
Mm-hmm.
Right, so that's just given. Okay, but we want to find out what is Z. I guess I called it X, I should call it Z, so let me fix that. Let's write a Z in there instead. So the key on this, just like we did before, is I'm going to draw the symmetric diagram. So over on this side, symmetrical, as best I can, that is going to be negative Z. Is that clear?
The Z doesn't stand for Z-score. It just stands for X.
That's a good question. It actually does stand for Z-score, and it stands for the X.
Okay.
If you have a mean of 0 and a standard deviation of 1, and you find the Z-score, well, if you subtract 0 and divide by 1, what did you just do? Nothing, right? Right, take a number, subtract 0, right? Think of a number in your head, subtract 0, divide by 1, and you didn't do anything, right? So that's why we call this Z, is it is a Z-score. Because if this were X, X minus 0 divided by 1 is still X, and that's the Z-score. That's the reason why we use the letter Z. Okay, but only if it's standard normal. Okay, so now I'm going to shade that in over there. And what is that area over on the left? The hint is it's really easy, very easy. Yeah, 0.025, because by symmetry, because normal curves are symmetric, left and right are the same. So if you look at the total left and right, You get 0.025 plus 0.025, which is 0.05. So how much is in the middle? What's left? This is supposed to be pretty easy.
0.050.
0.050 is how much is left and right. In the middle is 1 minus that, which is 0.95. So now we know 95% is in this middle area. And now we could use the empirical rule. So 95% of the data is between what and what for the Z. Do you remember? Based on empirical rule. Don't remember? -2 to 2. I don't know if you remember that. So that Z is 2, and we're done. Any questions on that?
I was thinking it was 3 because it was so far away from the middle, but it's 2 because it's 95%, and you just told us that under the empirical. Oh, okay.
Now you get it? Yeah, that's called the empirical rule. 95% of the data is between -2 and 2.
Okay.
When you have a normal distribution. For 3, it's 99.7%,
Okay.
which I used in the last example, right? Okay, so notice A, B, and D use one of each. That's why I did those 3, because I'm not going to do the rest because they're kind of redundant. I only do for some of these. Any questions on this? Okay, so now what I want to do is I want to do a different kind of problem. But it's going to have some similarities, so let me erase this all. By the way, I'm going to give you 1, 2, 3, or I'm going to erase it. Going once, going twice. Gone. Okay, and note, remember, this is all recorded on YouTube too. Probably tonight. We'll see tonight or tomorrow morning. All right, so now let's do another example. And I'm going to do some of these. I have a whole bunch ready just in case, but I don't need to do them all. Just a second. Okay, so now let's use your calculator. Okay, so suppose that X follows a normal distribution with mean 114 and standard deviation 23. Okay, let's do the first one. Find the probability that X is between 100 and 120. Okay, so the first thing we have to do, which I want you to always do, is write down the distribution. That is X this time, and then tilde, N, and then 114, comma 23. Any questions on that? So I want you to get used to doing that. Next, I'm going to draw the picture. Picture for this class, almost the rest of the whole quarter, it's always going to be the normal picture. Okay, and if you're as bad an artist as me, that's fine. It should look somewhat normal. Okay, but now the center is not 0 anymore. What's the center at? Yeah, 114. So the center of the picture should be 114. We want to find the probability that X is between 100 and 120. So what I do is in the picture, I can go to 100, somewhere to the left of 114, and 120, so somewhere to the right of 114. I'm going to label those. And then I'm going to shade in that region. Any questions at all on the picture? Okay, so now the next thing is I'm going to go to my calculator. So let's do that. I need to do a new share. And let's clear what we had. Okay, so the way you do it is you go to second distribution. And the good news, unlike the binomial, it's right near the top. But unfortunately, the one thing I don't like about these Texans is that they chose number 1 to be normal PDF, which no one ever uses in an elementary statistics class. So if you ever find yourself hitting that number 1, think again. Number 2, on the other hand, that's the most important, and that's normal CDF. And I'm going to hit enter. There are 2 kinds of the TI 8384s. This is one of them, where it asks you for the lower, upper, mu, and sigma. And the other kind doesn't. And then you just type in the lower, the upper, mu, and sigma, separated by commas, and then hit enter. If you look at my kind of videos, the regular videos, that has the other kind. So you get one of each. That's what I try to do. So I don't know which ones you have, but you'll find out when you click the button. So in this case, the lower was 100, because we want to find the probability between 100 and 120. The upper is 120. The mean was 114. And the standard deviation was 23. Any questions so far? I hit paste. And then I hit enter. So if you have the other kind, you're going to type in what we just saw, what this looks like right here, with the commas and everything. And you get about 0.33. Okay. On the computer, on the assignments, I think it's going to ask you for 4 decimal places. So make sure you put 0.3315. Use rules of rounding and all that. Any questions on that? Not too bad, is it? All right, let me go back to Paint. Let's do another one or two. All right, let's look at, how about C? Probability that X is less than 90. So again, same thing. Draw my picture. Like so. The center is going to be 114. That hasn't changed. 90 is over here somewhere. And less than 90 is all of this stuff. Any questions so far on what I just did? Okay, so now we can go back to our calculator and we can start computing. And I'll show you there's some issues now that happen. Okay, so now if I go to second distribution and I go to normal CDF, so if we look at this, less than 90, how far left do we go? Any thoughts?
To infinity? Like negative infinity?
Negative infinity, but negative infinity isn't a number. Do you guys know that? So we have to trick the calculator. And the way what I recommend tricking the calculator is pick a number that is so extraordinarily large that you're all right. And what I recommend is look at the number of digits we've got. We got 3-digit numbers, right? So go negative 999 and 2 more 9s. And that's close enough to negative infinity that it'll give you it'll give you the right answer to any number of decimals. So I recommend adding 2 more 9s in the number of digits that you have for the biggest number. Any questions on that? Okay, so that's something to note, is that you can't put in infinity and negative infinity. So you trick the calculator with really little numbers like negative 99999, or really big numbers like positive 99999 if you want positive infinity. The upper bound was 90. The mean and standard deviation are the same. So I'm going to hit enter and enter again. And this is what we get. Just a note, I want to do one more of these. I'm just going to make one up quickly. What if instead of 90, what if they gave you 5? Okay, so I'm going to go to 5. Let's see. Hopefully this will do what I want to do. Otherwise, I'm going to pick another one. So is the probability 1.07? What do you think? Okay, so the hope is you should all be saying no, and some of you are saying no. Probability can never be 1.07. Never, ever allow yourself to write down a number like 1.07 for a probability. Probabilities can't be bigger than 1. So what did I miss? Yeah, it's in scientific notation. This E-6 means that we're moving the decimal place over 6 to the left. So it's actually 0 point, and then 1, 2, 3, 4, 5, 1, 0, 7. And that's the probability, very, very small probability. So I did wanted to show you what it looks like in your calculator. When you get really little numbers, it'll throw a scientific notation at you. And you have to be able to recognize that. If you give me 1.07, it won't be right. Any questions at all on this example? Okay, let me do another one. Okay, so let's find the z-score for the value of, let's find the IQR is what I want. I want to find the IQR. Nice review of for your project. So you got to remember what the IQR is, of course, because if you don't remember what it is, you can't do this problem. Who remembers what the IQR is? What's the definition of the IQR? While I keep drawing here. I'm not seeing you all jump in on the chat box for talking, but what's the IQR? Yeah, interquartile range. So what that means is we're going to have two values. One of them usually called Q1, and the other you're going to call Q2. And we know that the area to the left of Q1 is how much? What is that area?
0.25.
Yeah, 0.25. And the area to the left of sorry, not Q2. That's a mistake. Q3, I should say. The area to the left of Q3 is how much?
0.75.
Yeah, 0.75. Great. Any questions so far? Okay, so we need to find the values such that the area to the left is 0.25 and the area to the left is 0.75. So here's how we do it. Obviously, we go to our calculator. I don't know if that's obvious to you, but that's how we find any kind of calculation. And I'm going to go to second distribution. And now I'm going to use inv norm. So that's inverse. So if you remember inverse, it means go backwards. So this is a go backwards problem because we're given the area and we're trying to find the value on the x-axis. Whereas going forwards, we're given the x-axis value and we're trying to find the area. So we're going to go inv norm. The area now is 0.25 for the first one. Mu was 114. Standard deviation was 23. And I just paste. And, oh, I think I got a problem because let me erase this. Let's clear all this out. It pasted onto something. So I'm going to do it one more time. Second distribution, inv norm. There we go. And I get about 98. Then I'm going to do the same thing with 0.75. .75, all the rest is the same. And I hit enter, and enter again, and I get about 130. So 130 minus 98 is 32. And there's my IQR. Any questions? Did I lose anybody on that idea? So notice we had to go backwards, so we're using inv norm instead of normal CDF. Okay, I have one more question to do. It's a fun one. Of course, for some of you, that's an oxymoron when you're doing math, but hopefully you'll like it. Just 1 second. Okay, so here's the question. So suppose the time until you, or your wife if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. So the interesting thing is this used to be pretty true, actually. Mean 140 days means that when you go to the doctor, they say that you're due in 140 days. That's what that means. Standard deviation is 7 days. If there is no medical intervention, that's about right. There's about a standard deviation about a week for giving birth, in terms of when they look at you versus how much time it takes before you actually give birth from conception. So it's a nice little interesting trivial fact. I don't know if you call it trivial, it's pretty important, but not a fact we have to know for sure. Okay, your boss has just scheduled you, or your wife, okay, if you happen to be male, for a business trip to China. Okay, imagine being pregnant, you're working, and your boss says you have to go to China. Okay, probably not too happy about it. Okay, but you don't want to lose your job either. You're still working. Okay, you or your wife leave today and will return in 135 days. Find the probability that your baby will be born in China. Any questions on the question? Okay, so as always, we draw our beautiful normal curve. Now the mean is 140. Okay, and we want to find out if the baby's born in China. And basically 0 days, by the way, is so far away from 140, we can call it negative infinity. That kind of like tricking the calculator, because it's so many standard deviations away from 140. It's 20 standard deviations away. And remember, 3 standard deviations as far as you need. So in particular, we're going to return in 135 days. The baby will be born in China if it happens before then. Any questions on that? And I guess I should write, because I told you it's important. You can say x tilde n 140, comma 7. Any questions so far? So let's find out this area. So we're going to go to our calculator. I'm going to go to second distribution, normal CDF, because this time we want to find the area. We're given the value of x. Our lower is, I'm going to go negative 5 nines is good enough. Our upper is going to be 135. Our mean was 140. And the standard deviation was 7. And I hit paste and enter. All right, so about a 24% chance. So what do you think? Would you be happy? Would you be okay with that if you're pregnant? To have a 24% chance that you're going to be in China and you're going to have to deal with that. Your baby is being born in China, can never be present in the United States, by the way, because you have to be born in America. Still okay? Okay. Chris, you may not stay married very long. You shouldn't be okay with that. Okay? You should not be okay with 24% chance that you're going to be out of the country for your birth of the baby. That's not okay. So that's just a little kind of a social.
They wouldn't let you fly then anyway.
What's that?
They wouldn't let you fly then anyway.
Yeah, well, if you're a man, they would. But still, you need to be with your wife, or you shouldn't be in China. They'd let you fly. They wouldn't let you fly home.
When you're a week away,
Huh?
you can't go on an airplane a week
No,
away.
you're flying on day 0. You can't get back is a problem. So it's bad.
Don't
You don't
recommend
do that.
it.
You don't want to do that. So let's go for the next question. So you decide that it's too risky. You want to negotiate with your boss to ensure that there's no more than 1% chance that the baby will be born in China. What day should you ask for the return date to be? So what I'm going to do is I'm going to draw a picture again. Hopefully you're getting used to the picture. It's always the same.
Day 123.
So there's our normal curve. Our mean was 140. And now what we know is we want to make sure that there's only a 1% chance that the baby's going to be born in China. So you're going to come back early, like there. So that area is 0.01. And we need to find x. So when you're given an area and we want to find x, what do we use in the calculator? And you remember?
INV norm.
INV norm. So I'm going to go ahead and go to second distribution. INV norm. Our area is 0.01. Our mean was 140. And the standard deviation is 7. Hit enter. So it says return in 123.7. Of course, you're going to tell your boss 123. Any questions on this idea? Any questions on that? Okay, let's do the last one and we'll call it a night. Okay, so it's now 138 days later, and the baby still has not been born. You're back in America, okay, which is a good thing. Find the probability the baby will be born in the next 24 hours. So for this one, before I even go to the picture, I just want to write down what this is. We now have information. We want the probability that the baby is born in between day 138 and day 139. So we want to find out the probability that x is between 138 and 139, given that x was greater than 138. Any questions on that? Okay, so now from chapter 3, we get a formula. That's the probability of both of these happening. If it's in between 138 and 139 and it's greater than 138, that's the same as it's between 138 and 139. So 138 is less than x is less than 139 divided by the probability that x is greater than 138. Any questions on that? So if I go to my calculator, let's go and go second distribution. Let's go to normal CDF. We're going to go 138 for the lower, 139 for the upper. The mean was 140. The standard deviation was 7. Pop that in. And that is 0.05565 or so. And then I'm also going to look at the same thing, except now we're going to be greater than 138. So 138 to a bunch of 9s. And that's 0.61245. So now I just divide 0.05565 divided by 0.61245. Oops, I lost it. 0.5565 divided by 0.61245. So we're looking at about a 91% chance that baby will be born in the next 24 hours. I think I lost a 0. So it's actually a 9% chance. Should be 0.05565 in my calculation. But if I go second entry, you don't know, that's a little trick. Second insert, stick a 0 in there. No, one more. There we go. And there we go, about 9% chance. So that's all I have to say. We're about 10 seconds before 7, so told you it would be less than an hour, not by much. But what I will do is give you the secret word. And the secret word is shade. Because you need to shade in the normal curve to find out what the area is. Okay, so that's pretty much all I have to say about the normal distribution. It is important. I just want to let you know it is really important. We're going to be using this a lot for the next several weeks. But I will be happy to answer any questions you might have, whether it's about the project or about what I just talked about or anything else. And I'm happy to help them.
Can you do the standard distribution on the calculator like you did all this other stuff? Is there like a trick to doing this instead of going the number minus the mean times or squared and then is there an easy, fast way of doing that, or do you have to work it out number by number?
When you mean standard deviation?
Yeah, sorry.
And you have a bunch of numbers?
Yeah, like if you have...
No, is this for your project or is this for homework? I mean, it's for assignment.
Oh, it's for the assignments. It's for a past assignment. I was just talking to...
Sure, yeah. Sure, let me show you. It's very simple. If you have data, let me show you in the calculator.
Oh, okay.
You go to Stat, Edit. You go to L1, clear it. Don't delete, clear it. Now, give me some numbers you want to learn the standard deviation of.
5, 6, 10, 11.
So 5, enter, 6, enter, 10, enter, 11, enter. Any questions so far?
Edit.
Then I go to stat again, and I go to calc. I hit enter for one pair of stats. If you have the newer kind of calculator, this kind, it's going to look like this. List 1 is L1. List 2 is nothing. Freak list is nothing. Leave it blank. And calculate. So our standard deviation, if it's a sample standard deviation, so if it's considered a sample, it's about 2.943. If that was a list for the population, it's 2.549.
Why does this look familiar? Did you already teach this to us?
Uh-huh.
Back in chapter 2?
Uh-huh. But again, we're in the time to answer questions, so any question you have, I'm always happy to answer.
Okay.
And there's videos on this too. Yeah, so this gives you all the data. Remember, you can't use your calculator for the project, you have to use Canvas, which is even easier. Just type in the numbers, it shows it to you. Any other questions?
I have a question on the last assignment.
Uh-huh.
And you posted, I had a hard time when I was trying to calculate given.
Uh-huh.
And you explained it on there, but like I said, the tutor told me that I had to take like when it was a problem where you give a second of the problem, like you say, if the bus takes 30 minutes, between 30 minutes and a minute, but you've already been waiting like 2 minutes.
Mm-hmm.
That's the standard deviation. And
it was a uniform distribution probably, right?
Yes.
Okay, so I'm going to draw a picture as you talk.
So
these uniform between what and what?
So the uniform is between, let's say, 1 and 30 minutes.
Okay, so 1 and 30. Now, are you okay knowing that the height is going to be 1/29? Or do you want me to explain that?
No, I'm okay with the height being 1/29.
Okay, so the height will be 1/29.
Correct.
Then you want to find out the probability. It helps you actually write in symbols.
Right.
That you are
30 less than x, given that x is less than 1.
Okay, probably not 30, because 30 is 100%, right?
Okay.
So maybe you should pick a different number. Not 30 and 1.
25 minutes.
Okay, so x is less than 25, given that x is greater than, and give me a number?
4.
4. 1 doesn't tell you anything. Do you understand that?
Right.
Yeah, that would just be like a trick question.
Right.
Okay, and the key is, just like we did this on the one just above it, kind of nice it's still there. It's going to be very similar.
When do you determine what to use? Because I kept doing like probability, just like you did it on there. But what the question was is that this person had already been waiting like 2 minutes.
Uh-huh. In this case, 4 minutes is what you're saying, right?
No.
If
So,
it was 2, there'd be a 2 instead of a 4.
okay, so the way the problem was written was you're giving this number by this number. It was when the waves, like the waves are going to hit at 35 seconds, and they normally are from 10 seconds, but you've been waiting there like 2 seconds.
Right.
So,
Right. So it does look a lot like here, except we're using the number 4 instead of 2.
Okay.
Do you see that? So this would be the waves. The waves go between 1 and 30 seconds, but you've already been waiting 4 seconds. What's the probability that the next wave will hit in less than 25 seconds?
Right.
Okay. So in this case, it's probability that x is so it's probability of both of these happening, which means we're less than 25 and greater than 4.
Mm-hmm.
See how I wrote that in the numerator?
Mm-hmm.
Divided by the probability of the right-hand side, probability that x is greater than 4.
Okay.
Any questions on that?
How come it's not? Okay, yes, the probability of greater than 4, yes. Okay, yes, that's what I was doing. Yes.
Okay, so then you go equal.
Uh-huh.
And now you work it out. Well, the probability that x is between 4 and 25. Let me draw the picture. Will be the area of that shaded region. Is that clear?
Correct.
Okay. And that is going to be 25 minus 4 is the base. Is that clear?
Yes.
And the height is 1 over 29.
Right.
Okay. Now for the probability that x is greater than 4, that is going to be everything to the right of 4. So that is going to be this part of the rectangle. Is that clear?
So you have to include 30 too?
It goes all the way to 30 because greater than 4 goes as far as you can possibly go.
Okay.
Do you see that?
Mm-hmm.
It doesn't get cut off by anything. But 30 is the highest it can go, right? Just
Right.
because it's uniform. Okay, and that again is going to be the base times the height. Now it's going to be 30 times minus 4. Times 1 over 29.
Right.
Which happens to be 21 over 26.
Yeah.
If you work it out.
Right.
Does that help, or is that what you wanted to see?
Yeah, I kept forgetting to do that. But then the tutor said that we had to change the height because you had been waiting 4 minutes. So it's a different height than that, and that was your denominator.
I hate to say this, but the tutor is wrong.
Okay, see that totally like confused
Yeah,
me.
sorry about that.
And I didn't understand why it had to be dropped because he was saying now you need to change and you just divide it by. But he got the answer right.
Right, there's another way of doing it with a different picture, but the way I'm showing you, using the given formula, and one of the reasons why I show you this is notice it happened again in this chapter. So if you just learn this technique, it works for everything. Anytime you're given. Does that make sense?
He got the right answer, and he was like.
Right, but it was trickier. So I recommend not trying to pull out tricks if you don't have to.
Okay.
So I didn't pull out any tricks. I just used the definition of given. Do you see that?
So the formula is always, when the problem is given, you're always going to use the same?
Yeah, so let me write down in the formal formula is probability of A given B is always equal to the probability of A and B divided by the probability of B.
Right. So that never changes.
Yeah, that is a math formula. Math formulas never change.
Okay. Okay, sounds good.
Yeah. So the reason why I always do it this way is that way you're always consistent in anything you ever get. Does that make sense?
Okay.
There are tricky ways of doing it, but I try not to show you tricky ways. I try to show you straightforward ways. I think it's easier to learn.
Well, it threw me completely off, and then I didn't know what to do after that.
Right. Do you understand this way?
Yeah, I understand that.
Yeah.
Now
Good.
For the exam, you want the pictures.
Pictures are important. Yeah, you will lose points if you don't give me a picture. And even better, you'll get points if you get the picture, even if you get the rest wrong.
Okay. Okay.
You see?
Now,
so look at me being nice by asking you to put the pictures in because it's a way to get some points.
And you want pictures for every single portion, right?
Yeah, I let you know if you hear the word uniform,
Uh-huh.
then what should the shape of your picture be?
Square.
Yeah, rectangle actually, right?
I'm sorry.
If you hear the word normal, what should the shape of your picture be?
Little thingy,
Bell.
a bell. Okay.
Bell. Bell is the shape we usually call it. Okay,
Okay.
which we call it normal, but so look for those words. They're not trick questions, it's always there. You'll notice in this question it says normally distributed towards the top. Do you see that?
So you always have to have a drawing of a bell or a rectangle.
For everything in chapters 5 and 6.
Okay. Now
Okay.
with
And 7 actually too, but we're not there yet.
can you show me how to do the 96th percentile of like one of the questions in the last chapter as well?
Okay, should we just do this one? Should we do the 96th percentile on this one?
Sure.
Okay, so in this case, the 96th percentile, let's see, I haven't used brown yet. It's getting a little busy, that's the only problem. It's getting way over here in brown. I'll make it thick and dark. Okay? And we can draw everything to the left. That area is 0.96.
You should always include 0 though, right?
Well, it stops at 1. If it's a uniform between
Why
1 and
not
30,
0?
then it would go to 1, right?
You mean
It can't
0
get under
point?
1.
Is that what you're asking about, Claudia? 0.96?
No, 0.96. No, the 96.
Oh, you mean should I have a 0.96? Is that what you mean?
No. Shouldn't you include the 0 on the number line?
No, because 1 is the farthest left it'll ever go, and because when it's uniform between 1 and 30.
Okay.
Right.
Oh, okay. Okay, now I got it. Yes.
So let me write that down. X tilde U 1 comma 30. So that's from that.
Okay, got it.
You don't go below 1 if it's uniform from 1 to 30. Just like we didn't go above 30.
Okay.
Okay. So now what we don't know is this value on the x-axis. And when you don't know the value on an x-axis, you call it x.
Right.
So now we go ahead and do the area formula. The base is going to be x minus 1. Is that clear?
Correct.
The height is 1 over 29.
Right.
And the area is 0.96.
Right.
Any questions on that?
No.
Now algebra,
Right.
which you probably love, right?
I actually do love algebra.
Good, then you better be able to do this. Multiply left and right by what number?
29.
29, and we get x minus 1 is equal to 0.96 times 29.
Right.
Now what do we do to both sides?
You add them.
Add what?
You add a 1.
Good, we add 1 to both sides, and we get x equals 1 plus 0.96
times 29.
times 29. And then you stick it in the calculator.
Right. I kept
Does
getting
that help?
I kept getting different answers.
Yeah, maybe you're reading the question wrong. I mean, it's hard to know what was wrong if I don't see it. You know what I mean? But this is how you do a percentile.
That was exactly the steps that I was following.
Maybe you were doing one of the numbers wrong. It's really hard for me to know what went wrong unless I see it. You know what I mean?
Yeah, I got this weird numbers and the correct answers were different. But these are the steps that I was following. And, so I don't understand what I was doing wrong. And it worked like, the funny part is that it worked when you would ask the first quartile or the last quartile, because I knew the last was 75 and the first was 25. So, and I did the same calculation and I got it right. But when you would ask like the 96 or the 72 or any other percent percent to figure out, I would get it wrong. So I was super frustrated because I was getting it right on some and I was getting it wrong on others.
Yeah, one thing you might want to do is if you can copy and paste it into the Q&As, then I can actually see what you did.
Okay.
And then maybe find the mistake. You probably made a mistake somewhere. It could have been in your calculator for all I know.
I was doing that by hand. I wasn't even using the calculator. And then I would check
well, this one you wouldn't want to do by hand. I mean, you could, but it's ugly.
Right. Okay. Sounds good. Well, thank you.
Okay. Well, thank you for asking questions. That's the whole point.
Appreciate it. So any recommendations on your past students for tutoring?
And you live in Tahoe? There's some good students.
How would I get a hold of them?
I'll tell you, let's see if I can. In the afternoon, there's a couple of them that always hang out by the bio, the little bio study area? There's a couple of statistics students that are good students that are always hanging there.
I get off of work at 5 and I work in Carson. So it
takes... So you probably won't find them.
Yeah, it takes me 45 minutes to get home. So I commute 5 minutes.
Right. I'm thinking like early afternoon and you weren't not there. I'm just saying, you could find them that way.
Even, if I can pay them a little,
Right. And like I said, what I don't do is run a business. So any money is not my business. You got it?
Right.
You offer it. If they say no, then you understand it. If they say yes, that's fine. But I'm not going to tell you how much to ask to offer. But I can ask them to see if they can contact you.
That would be awesome.
Do I have permission to give them your email?
Yes.
Okay.
Even give them my number, I'll send it to you.
Okay, because I have to find a way to get them to get a hold of you. Does that make sense?
Yeah. Okay.
Okay.
Thank you. Have a good night.
On the test, did you see my note about the proctor?
Yeah, let me know. It's a little too early now.
Oh, it is?
Yeah, we're not taking the test for like another month.
What?
The test isn't for like a month.
Well, I know, but you said like weeks ago that we were supposed to start looking for one. And I was like panicked thinking, oh crap, I haven't done that yet.
Oh no, just start looking doesn't mean you have to panic.
Okay, well I found one.
It just means don't tell me the day before you're going to take it.
Okay, that's fine.
They're usually like 7 or 8 days before you take it. Send me an email.
Okay, well she said give you the email address, and she's in Placentia. She's like 10 miles from me, and she's like the cheapest game in town, but she's a librarian. And
okay, as long as there's a website with her name on it in the library.
I don't know.
So I need to somehow be able to verify that she's a librarian. Does that make sense? Or if I called the library and she answered, that would be enough.
Her name, and then at placentalibrary.org.
Right, but wait until about a week before the test.
All right, I'll do it again. Okay.
I'm not even going there. Right now I'm trying to help everyone with projects.
Or is it going to be a written paper one, or how's that going to work?
The test?
Yeah, is it online or is it on paper?
It's on paper. The test is going to look just like you're not taking an online class.
Good, okay. Because I
can do a regular old test with a bunch of problems, space to write it out.
Good.
You can have 2 hours. You're going to turn it in. She's going to take a picture of it, email it to me, and then I'll grade it.
Okay.
Does that make sense? Okay. And it's like lots of pages of pictures.
How many of your students have failed this test?
Anyone hear this? No.
Well, the funny thing is, most of the ones that fail the class don't fail the test because they don't take the test.
What? What do you mean? They don't have to take the test?
No one has to take the test, but they fail.
You don't have to do anything in the class. You could do nothing and you just take the class and you can fail, but you could just do nothing.
I thought maybe they did so well in the class they didn't have to take the test.
No. But I get a lot of students that just fail because they didn't do anything.
Okay.
You're not that kind of person. No one in this class is like that, which is amazing because usually about a third of the students are like that.
Okay.
So I have a really good group this quarter.
Claudia, you can always, you can always call me and we can do the work together, because when I do it with somebody, it seems to help me figure it out a little better.
Yeah, what,
Always welcome to call me. You know what? I don't know how to get my number to you.
I'll send you an instant message with, I mean, a Canvas will send you
Just
an
take my
email.
number down real quick.
Okay.
714.
714?
Yeah, and I'll have a whole webinar that's mostly for the test, by the way.
272.
273?
272.
Okay.
4733. And then just call
Okay,
me
thank
and
you.
we can do it together because it helps me too. So. And I
Okay.
need it. Okay.
Great. Thank you very much. Have a great night.
You
Okay.
too. Have a great night.
Good night, everybody.
Good night.
Night.
Good night.
I
Sean,
had
any
a-
questions?
I had a question about the proctored exam as well. I
Okay.
found a proctor, but because it's at a college, it could potentially fill up, and so she did want to have your contact information.
Oh, you could definitely give her my contact information. That's always okay.
And then she wanted me to send you her contact information as well.
That's fine. But I haven't written the test yet, so if you need me to send her the test, I can't.
Okay, I'll email her and ask her if she can save the dates for me, because basically I can either take it on Tuesday or Wednesday, because the school doesn't offer anything on Mondays. It's only Tuesday, Wednesday, or Thursday.
Okay. Yeah, and it's a good idea to get advanced reservation.
Right. I sent her the information for both the final and the midterm, so I'm hoping that she'll save the dates. So I'll ask her if she could possibly save those dates, and then I'll send you the contact information for her.
Great. And again, I haven't written the test yet. I need to wait because I never know, like there might be emphasis or something that I need to test more on or less on.
Right.
So it's too early for me to even write it. Does that make sense?
No, that makes sense. I want to make sure that I keep my dates, because that's pretty much the closest place I can get that's not like a local library, or because it's a community college up in Sonora, so it's a little easier for me just to go over there after, like during work time. I can just take some time off work, maybe an hour or two. Is there a time frame for how long this test will be?
2 hours.
2 hours? Okay.
Yeah. 2 hours each test.
Okay, so it'll be 2 hour time frame, and then whenever we finish it, kind of thing.
Yeah, I mean, my recommendation is if you've only got an hour and a half, go back and rework problems and make sure you get everything right. You know what I mean?
I usually take majority of the time, especially for math, just to make sure.
Yeah.
But if I've gone over the test once and then basically gone through the test entirely two times, usually I'm pretty good, because after that I start second guessing myself and I start messing things up.
All right, whatever works for you.
Okay, that's about it. So you'll probably be seeing an email from me shortly, probably the next day or two, with her contact info.
Okay, and the project is what you should really be thinking about right now.
No, I know. I've got some. I'll probably be posting more questions in the project discussion. I posted one last night. I'm not sure if you got to it yet.
If it was last night, I got to it.
Okay, I haven't looked yet. I've been basically. I went from work to here pretty much. So
I've answered about a lot of them already today.
A lot of them. Okay. Well, I will probably keep posting questions there if I have any, and I'm going to be trying to start writing some of the paper probably tonight.
Yeah, with your partners, hopefully.
Hopefully, one of my partners is in the hospital, she was saying.
Oh, she's the one with the spine injury.
Yeah.
That's right.
So I'm not sure. We're trying to figure out how we can all work.
I talked to her on the phone.
Yeah.
So she is going to have internet access. Her brain is just fine.
Right.
Type. So she can't do the data collection.
Okay.
She can't walk around. And I told her to tell you guys got to do the data collection.
Right.
You're okay with that. But she's going to help with the writing of the project.
Okay. Well, I'll probably be doing the data collection then a bit more. I need to get some more data, because I did some of the data collection, and then we found out about this, so I need to do more data collection. But it's hard for me to find time to do it since I'm working.
Yeah. Well, you have a third partner, don't you?
Yeah, we have one other partner.
Yeah,
and
so
she's
two of you
doing
can split the job on that.
Right. So we should get
that should be quick, actually.
Right. We should only what was it? We only had a minimum of. We need a minimum of 31.
Yes.
Okay.
And you'll get more points if you get 100. You know what I mean?
If we get more points, if we get 100 people.
If you get 100 people, I don't give you any more points because you got 100. The point is, don't try and get a huge number.
Right.
Don't spend all your time doing the surveying. Make sure you spend your time doing the writing.
Okay. Well, we'll see what my other partner got for the amount of people, and I'll try to at least shoot for probably 31 and probably a little bit more, probably 40 or so.
I mean, you might do 32, 33, that's okay, but don't do 100.
Right. I didn't want to focus on getting too much data since the minimum was on 130. I think you mentioned before as well that we don't want to have too much data for this and to focus more on the paper.
Yeah, because then you only have so much time and energy, and I'd rather you have time and energy in writing the paper.
Right. So I had a question about the paper in the sense of the diagrams. Is the diagrams part of the paper page count?
Well, I don't have a page count minimum.
Okay.
So,
but I was just wondering. I was just wondering if that counts towards it because we were just wanting to shoot for a relative page count.
Yeah, typically there's if you exclude the diagrams, it's usually like six, seven pages, something like that.
Okay, so kind of like an introductory paragraph and then description of each of the diagrams and then the data analysis, a conclusion, and the meaningfulness of the data. I'm assuming those are the broad stroking.
Yeah, and don't forget that you're always making recommendation to your client.
Right, and that would be during the data analysis portions of each graph.
Right.
Okay.
And the statistics, the mean, the standard deviation.
Right. Standard deviation and all of that.
Chevy Cheddar's or empirical rule, all that.
If I have questions about working on the spreadsheet, should I post them in the project discussion as well?
Yeah.
Okay.
It should be really easy for you. You just type in the numbers, it just does it for you.
It's on the left column, right? The A column, you just type in the numbers from our surveys and then
move your eyeball. Yep.
Okay.
That's all you have to do. Just move your eyeballs.
Okay. Sounds good. Then I will I'll start working on it and I'll probably be in touch in the project discussion if I have any questions.
And make sure you do make a copy the first time you use it.
Oh, I have the original copy in my drive right now, and I'll probably make a couple copies. I usually at least make one.
You only need one, but if you don't make a copy, you won't be able to add any numbers in.
Oh, I've already done that. I've added it to my drive, so I made a copy to my drive already. So that was no problem.
Good. Then it should be really easy.
Right. Okay.
Okay.
Awesome. Thank you very much.
All right. Have a good night.
You too.
And for all of you who are watching as a archive video, thanks for watching and have a wonderful night. Please get to work on your project early and post questions, and I'm here to help out. Have a good night.